Hello, welcome to the Augmented Instruments Lab session at Imperial College, and we have Tom Richards here, artist and engineer, talking about his work with Oram's Mini Oramics Machine.
Thanks, Sarah. Hi. I'm have many hats, jack of many trades and master of none, but yeah, basically trained in art, moved sideways into sort of sound art and music, and at the same time had a side career of being a sound engineer, acoustician, DJ, electronics engineer, AV technician, and then latterly a researcher and instrument designer as well. So there's many things I could talk to you about, but today we're going to focus on Daphne Oram, who is an amazing British pioneer of electronic music, an amazing composer, and also someone who was really fundamental to the development of electronic sound and music in the UK. So she started off, she cut her teeth at the BBC. So she first of all started out having a position as what was called a junior music balancer. So that was someone who just sort of looked after record playback on the radio. But she was trained up then and became a studio manager. But in fact, one of her first jobs, like just before the end of the war, the Second World War, she was actually one of the first beat matching DJs, because she had this position where she would be playing recorded concerts at the same time as the live concerts in venues like the Albert Hall, just in case a bomb dropped, they could just flip it over to the recording. So she was beat matching to live orchestra in 1944. She got trained up at the BBC to be basically a studio engineer, and her title was studio manager. And this is an image of her with Desmond Briscoe, Dickie Bird, and somebody else who's probably a producer. I'm not sure who the other person is. That's towards the end of her BBC career. So she basically, throughout the early, mid to late 50s, was honing her skills and reading a lot about the potential for electronics in music and sound. And she kind of got quite obsessed with this idea of what you might call a universal instrument that was sort of theorized by people like Leopold Stokowski and Edgar Varese, in as much as the idea was that you could create an electronic machine where the composer could have their vision not touched by an orchestral interpretation. It could be read by the machine exactly as the composer intended. So she got really obsessed with this idea and spent a lot of time during the 50s trying to, talk to different people about how this might become possible. So she spent a lot of time out of hours at the BBC chasing down people in physics departments and acousticians and those kinds of specialists. And she's also somebody who mythologized, I think, a little bit about herself. So the kind of story that is always told about how she conceived of her ideas for her drawn sound interface was, she tells much later in life a recollection that she was in a BBC training session, and the engineer or trainer showed her basically her voice on an oscilloscope, so she could talk into a microphone and see the wiggly lines on the oscilloscope. And the story goes, she asked them, well, would it be possible to reverse the process to draw the waves and hear it? And was, in her version of events, sort of immediately smacked down, poo-pooed by this person. But I think actually having studied what she was actually looking at that time, she was looking at a lot of optomechanical and tape-based ideas for how. So I'm not sure if she's sort of somewhat embellishing her own history there, or it may have planted a seed and she just didn't know how to approach that avenue at the time, so she was approaching these other avenues. But there are some quite interesting, weird and wonderful devices she dreamed up before that part. But anyway, eventually at the BBC, she got very successful in the drama department and was kind of quite opposed by the music department, who, like many technological revolutions, were kind of scared of musicians losing their jobs. You know, the union, much like when the talking movies came out, all the organists went on strike, and the people who used to play the music in the theatres. Kind of a similar scare around electronic music at that time. Musicians and people who, unions for musicians and stuff, and people like the BBC music department were kind of a bit opposed, or quite worried about what the implications might be. So she found she got a lot of support from the experimental drama producers at the BBC, and her early electronic music commissions were pretty much exclusively from the BBC drama department. So I think her first televised soundtrack was for a show called Amphitryon 38, a sort of sci-fi production. I think that was 57 or 58. I'm sorry, I'm a bit rusty. So other notable things, in 1958 she was taken on a trip by the BBC to the Brussels World Fair. So she'd already been basically pursuing electronic music in her own time outside of hours to create the skills for what was really composing it in a musique concrète style, tape manipulation, speeding up, speeding down, reversing, bouncing down, mixing things together. So she was already quite accomplished at this, and then in October 58 she went to the Brussels World Fair, and I think it was a revelation for her. She really saw how, she saw people like Pierre-Henri, Pierre Schaeffer, Karl-Heinz Stockhausen, Edgar Varese, and many other, Luciano Berio. All of these people were presenting their work at that fair, and I think she really, at that point, the penny dropped how much more this work was being supported in Europe, and she increasingly was feeling undervalued at the BBC. Of course, that same year, she became the founder member of the BBC Radiophonic Workshop, along with Desmond Briscoe and Dickie Bird, who was their technician. But I think by that point, on the inauguration of the BBC Radiophonic Workshop, she was already feeling undermined, because largely the electronic soundtracks that were being produced by the BBC were pretty much exclusively her, and she felt that she wasn't listened to in terms of the equipment they wanted, the equipment they needed, and so she felt undermined. And then also she was really cross about the lack of credit. So when her work was televised, was broadcast, she wouldn't have a named credit like a composer would have. So there's a letter that she writes to her mother about this time, basically outlining all her grievances with the BBC. So it's really there clearly in black and white what her kind of grievances were. And so quite shortly after the inauguration of the Radiophonic Workshop, she decided to leave and form her own private studio. I believe she's probably the first woman in the world to create their own private electronic music studio. And then, she then really set out to further pursue her ideas for this graphic sound machine or universal instrument. She applied for some money, I think she probably put the net quite widely, but she ended up getting a reasonable grant from the Calouste Gulbenkian Foundation for £3,500 to create her machine that she kind of had in her head conceptually, but she still didn't know how she was going to do it. And she got this £3,500, which is probably equivalent to something like a funded PhD now. It's not going to make you rich, it's not tons of money, but it's enough to definitely make a good start. So I think when I wrote my PhD, I looked at the sort of inflation translator, and it equated to about 55 or 60,000 pounds. So she initially started out with her brother John Oram, making a kind of mechanical framework that she could base her electronics that she was going to develop around. And initially she worked with an electronic engineer called Fred Wood, and they made quite slow progress kind of between 1961 to sort of 63. And I think at that point she then tracked down this fellow called Graham Wrench, who then really was able to do the sort of, he was a former radar engineer, so he had a much better idea of how to manipulate things like CRT screens, and basically he was the person who was able to make the electronics match the concept, really. So I'm just going to explain how her original machine worked. So first of all, if you were composing on the machine, you would draw some hand-drawn wave patterns. So those would equate to the tone or the timbres of the machine. And then you would place them into this weird-looking device, which has become colloquially known as the commode of the machine, although I think some of the Science Museum conservators realise it's probably the shell of an old radiogram. So you put your graphic slides into these into slots above these yellow tubes. So those yellow tubes are actually I think 5-inch or 4-inch CRT tubes, and then above them, each one is a component called a valve multiplier, a photo multiplier, sorry. And a feedback circuit basically means that the dot on the CRT can follow the waveform, and then you extrapolate the y-axis from that, and it's your tone, your output, basically. And above those tubes in the machine is the sort of master oscillator, which gives the dots on the tubes, the left to right repeating sweep to be able to then read the contours of the wave. So that's how pitch and timbre essentially are formed. Then there's this other part of the machine called the programmer that had 10 tracks of synchronized 35mm movie film, and with that part was basically the sequencer. That was putting the notes in order, and lots of, I think really importantly for the time, it had a lot of different means of expression. So if I quickly go through the channels, it actually essentially, like obviously she built this framework with her brother, or her brother built the framework before they really knew what they were going to do with it. So the 10 channels was almost an arbitrary decision, and I think there's some evidence that they considered different numbers of channels or tracks of this synchronized movie film. They settled on 10, and essentially she ended up using 9. One was kind of left as an auxiliary track that was maybe going to be used for things like switching on and off tape recorders or something, but essentially it used 9. So the tracks 2, 3, and 4 here at the top of the machine are 3 tracks of 4 channels of dots, so basically 12 inputs, which were a codified digital means of inserting a pitch value. That changed throughout the development of the machine. Initially, she wanted to go for decade-based, entering the frequency in hertz, basically in hundreds, tens, hundreds, thousands, etc. But obviously, that's not a very intuitive way to make music, entering a discrete pitch, so many lookup tables of like, what A is 4, 4, 2, what's B, B flat, whatever. So she did change that eventually to be, musical intervals and so on, and it changed many times over the evolution of the machine. So that's 3 channels that are the codified digital pitch. This red channel is the analog vibrato or pitch bend. So if you draw a quick wobbly line, it becomes vibrato, and if you draw a slow wobbly line, it would be like a pitch bend. So it's literally an analog. It's not codified, it's literally an analog of what it does to the pitch. And then, so that's the pitch control, and then these bottom 5 channels of graphs are all volume information. So you hand draw your own envelopes, so each note can be different, and you've got 4 oscillators, so you've got graphs 6, 7, 8, 9 are just literally graphical volume control for your 4 oscillators, and the last one, number 10, is the amount. So the 4 oscillators are mixed together, and then channel 5 is how much you send it to the reverb. So it's like an aux send, basically. So this is, this is her diagram of how it works. So this is literally what I've just explained to you. And that was from her writing up her Oramics system in her own book, an individual note, of sound, music, and electronics. So as I said, it's I spent quite a lot of time examining the actual machine itself, which is in the collection of the Science Museum in London, and it's a very odd machine. It's hard to analyse, and it seems like, as you know, between kind of 1966 and kind of 1973, which was basically the main era of it being used, a lot was added and not much was taken away. So there's a lot of sort of redundant wiring looms. There's sort of bits where she's changed her mind, she's pulled out some stuff and added it, but it's all still in there. Like, so it's very hard to sort of, it was never a static entity. So it's a funny old thing. So yeah, I would suggest anyone who wants to sort of know more detail about that, do have a look at my thesis. It sort of outlines some of the history. And I would say I've done a moderate job of getting a bit further with how it worked, but there's still a lot of mysteries. There's still a lot to do. I mean, for instance, the mechanical system in it is baffling, because the pitch controls have a completely different transport route for the film than the envelope channels, which doesn't make any sense to me. I can't think of a logical reason why that would be the case. But anyway, that's where we are. Excuse me 1 sec, I'll just get my water. Yeah, and I think there's also a question of whether, and I'm going to come on now to her, this document is what I've kind of taken out of the Oram archive, which is in safekeeping at special collections at Goldsmiths. This, I think, is pretty much about when she just got her first grant, and it's the closest thing that I can really find to something that you could call a coherent design brief. So this is before she's started work on the machine, but as she's thinking about how she's going to do it. And I'll read it out. So it's called Written Sound Waves, January 1961. Needs, number 1, to have complete control of timbre, pitch, dynamics, vibrato, reverberation, attack decay, and timbre changes within the note. Number 2, to control these characteristics in a visual form so that all alterations within the oral comprehension of the human ear and mind have an easily recognizable counterpart in the visual medium. To achieve this controlled complexity of waveform whilst keeping all parameters within the scope of written waveforms. And number 4, to obtain sounds which are more musical than those so far achieved by electronic devices, which have a far greater range of timbre. And then there's some comments. Neither the additive sine wave methods nor the subtractive white noise methods give satisfactorily musical timbre, because the results are, I think, too simple. There is not enough change within the note itself. Also, they are too mathematically pure and calculated. A freehand drawing method might produce very much more artistic results based on the inaccuracies inherent within it. Once a handwritten system has been decided upon, all stages in the composition technique should then be under its control, e.g. different strands of the score should not be left to be later mixed by conventional methods, but should be accurately combined by handwritten control, as were the original components of the sound waves themselves. And if the action of a bow on string is thought of in slow motion, it would seem that the string, in adjusting or readjusting to a certain speed of vibration, must give off a glissando sound, which is too quick for the ear to recognize as such, and which we just term attack. With a slow motion technique, this might well be produced far more accurately than any gating circuit can do it. So I think we can see her philosophy here, and I'm going to do some kind of comparisons in a minute, but she's looking for something where human expressivity and the kind of organic nature of musical sound, you know, with traditional instruments can be emulated electronically. And I think she saw a lot of other developments in electronic music at the time being quite sort of boffiny and mathematical, and she was very vocal about that. But I'll come back to that. So here's a little clip of her. So this is her on the radio on The World at One on the BBC in 1972, and it's just a little clip of her explaining her device that she's created.
Well, I was wanting to make some sort of trumpety sounds, but not exactly a trumpet. One doesn't want to copy sounds of normal instruments. And so I drew a wave pattern, and I gave that to the machine, and then I went and put some black dots on. Now this just gives me a number of pitches, one after the other. Let's hear those. Very dull. Now, we want to put vibrato, and we want to put reverberation, and we want to rephrase it and make it much more musical.
Yeah, so I think from that, even that little snippet of sound, you can hear that, you know, certainly to an extent, she's achieved her aims. And I think if you are, probably lots of you are very knowledgeable about like other electronic music sort of research that was going on at the time, sort of late 60s, early 70s. And it does sound remarkably musical and organic in comparison to lots of things. And I'm going to play you something in a minute to compare it with. But briefly, I'm going to have a look at... So my thesis, my study of Daphne Oram was kind of broken mainly into two parts. There was like examining the original machine that she made, and then the second part was the practice as research, which I'll come to in a second. But in terms of the studying the machine that she made in the, you know, throughout the 60s, I kind of came to the following conclusions: that it was, you know, ambitious, holistic, and a nuanced approach, but in practice it was pretty unreliable, ungainly, overcomplicated, with pretty limited musical output. There certainly is recorded music from it, but there's not very much evidence that long-form music was made in the way it was actually intended. So actually, I should have probably said that, but her idea was that you write a line of musical melody, bounce it to tape, and then rewind it all and write the next one, so that then you can do counterpoint and harmony and, you know, different instrumentation, different timbres for different parts and all of that sort of thing. So she really was thinking of it as a kind of orchestra in a box, or at least a quintet in a box or something, do you know what I mean? Yeah, unreliable. There's in the archive her logbooks of basically, you could call it trying to keep the damn thing working. That could literally be the title. She's spending hours on fiddling with it and maintenance for every hour she's composing. Ungainly, so it was hardwired into her studio in Kent, away from, you know, even if she'd stayed in London, maybe outcomes would have been different because people would have been more likely to come and see it, but it was hardwired into her house in Kent across 3 rooms. So she had the studio room, the room where the machine was quite noisy, so she had the mechanical part separate from the place where you listen to it, and then she had underground oil tank, I kid you not, was her reverb chamber. So she had a microphone and a speaker and the ancillary cabling to send the sound to the reverb tank and come back in. So as I said, limited musical output, mainly because of this trying to keep the damn thing working. And then, but it sounded amazing. And I think, you know, even just listening to that little snippet and the music I was playing for the intro, which was not entirely Oramics, but heavily featuring Oramics, yeah, it stands up today, doesn't it? In the, you know, we've got, it's an amazing sounding machine. And so that's my kind of conclusions about her thing. And you know, she's not daft. She realised all of the same things, and so that's what brings me onto the next chapter of what she did. But I'm just gonna. It's slightly disingenuous, this next thing, because it's actually a piece from 1959. But Oram was very vocal about her kind of disdain for not computers per se, but computer-generated music and aleatoric music and serialism and these sort of quite mathematical trends that were happening in music research at the time, which she either referred to as music by slide rule or music by the yard. And yeah, she was very vocal about her opinions on this. So I'm just going to play this little bit of music. So throughout her life, she was always talking to other researchers, composers, you know, all the important musical laboratories that were, you know, much better funded than she was and much, you know, had multiple employees in various places like Toronto, Paris, you know, the WDR in Germany, all of those kinds of places. So anyway, this is a little piece by Dr. J.R. Pierce from Bell Laboratories, obviously where Max Matthews was his colleague. Yeah, so this is... So, oh, sorry, that's, yeah, so I'm kind of just trying to give you an impression of the kind of tapes she'd have been receiving from these people in the post. You know, she was forever sending and receiving snippets of audio and music, and like in the archive, for instance, is that famous Daisy Daisy recording of the first, or some of the first computer speech. Yeah, so you can, listening to that, so she'll have heard those kind of works as she was thinking about how to develop her machine and what she wanted to do differently. So I think it's just, yeah, it's she just had such a radically different approach, I think. It's really amazing to hear the difference. And it's also just astonishing that she managed to, you know, her studio and her machine really stood up against these incredibly well-funded labs and research departments where, you know, people were on salaried, multiple employees with PhDs, all like, you know, giving their all to creating electronic sound. And she's doing this on a wing and a prayer in Kent with like 1 or 2 technicians. And yeah, it's astonishing. So that brings me to, yeah, so obviously she wasn't daft, and she realized some of the, you know, issues she had with this crazy machine she built. And you know, perhaps a little bit similarly to the way Robert Moog eventually found success with the Mini Moog. So he'd been selling giant, incredibly expensive modular synth systems that only like really rich rock and roll stars could afford. Obviously the Mini Moog came out, and that was what eventually made his company able to be profitable. And I think she realized she needed something that you could take in a suitcase and bring somewhere and turn up and, you know, work her system. So as she was kind of getting more and more frustrated with her giant Oramics machine that she had in her studio, she started thinking about creating what she called mini Oramics. And so quite early on in my research, I found this document, which is actually, as far as the archive goes, probably the most complete schematic for any system she ever designed. It actually has all the circuit diagrams for a complete system and an explanation of how it should all work. So I spent some time scratching my head about it and thinking about what it would mean to try and recreate this thing, and how should I approach it, and what should be the research question, and how should I I'm a person who likes building things. I really wanted to make it, and I had to find a sort of a justification within the context of doing a PhD. So I kind of came up with this kind of crass idea, the what-if methodology. And so my idea was that basically, having analysed her design, having built some of the circuits, having really done a deep dive into whether it seemed feasible, my conclusion kind of was that it wasn't that feasible, and if I built it as she had designed it, she'd obviously not prototyped it fully, and I think she would have realised the same drawbacks as she went along. And I really wanted there to be a way of experiencing what it's like to use Oramics as a musician, as a composer. I wanted to privilege having a working musical instrument. So I kind of came up with this idea that what if a significant commercial interest had taken on and perfected Mini Oramics and released it as a product in the early 1970s. So rather than building her design, which inherently I felt was compromised and wasn't fully finished as a design, because I really wanted artists and musicians to be able to use a working instrument. So that was what I did. I kind of pretended to be someone who'd taken her idea and was like, okay, now I'm going to perfect this idea and create an instrument. So I mean, I'll just explain a couple of the things I felt were major drawbacks with her design. The first one was that she was, similarly actually with the original Oramics machine, she was kind of quite obsessed with opacity of the drawing material. So basically using light sensing circuits, which really the light had to do the switching on and off. And as you probably realise, if you draw with like a permanent marker or a Sharpie onto a bit of cellophane, it doesn't become opaque. It just becomes a few percent darker, maybe 15-20% darker. So she spent a lot of time obsessing about this, because the circuits that she had in mind required that it went from fully lit to fully darkened on a sort of a light sensor. And in fact, if she really got quite hung up about this and eventually settled on, after doing her own experiments, that the best material, the best medium for this new machine would be greaseproof paper with an 8B pencil, like a mega carbony pencil. And I was just like, I am not going to build a machine that uses greaseproof paper and an 8B pencil. Can you imagine the smudges? I'm not someone who I don't like messy materials at the best of times, and certainly not in combining it with really fiddly microelectronics. So yeah, I certainly was like, okay, I will just use a comparator. There's just a little tiny bit of an op-amp circuit which can just say, I'm seeing the Sharpie, I'm not seeing the Sharpie, and you can set a threshold. So I just, was like, okay, that's solved, fine. The other thing she wanted to do was have, rather than the original machine having these CRT scanning oscillators built into her device, she wanted to build it around an actual external commercially available oscilloscope to kind of save development time and so on. And I tried that, and I built the circuits, and I could just about scan a wave pattern with this hood that goes over the front of the oscilloscope. But the minute you changed one little button on the oscilloscope, you changed the time base 1 degree or the scale 1, it would just stop working. And she was talking about she wanted these things to be in universities and schools and conservatoires and students to use them. And can you imagine the technician would just be forever coming and having to recalibrate the oscilloscope. And so I was like, it has to be in the box. It has to be and reliable. So I actually ended up using this, basically a sped up step sequencer. So these things that look like graphic equalizers on the top box in this image, they're just repetitively scanned voltage samples of a bunch of pots. And it has got this kind of quite harsh digital quality, so it's not perfect. It's not as beautiful and analog as the CRT method, but it also means you can change the timbre as you're playing it. So it has this advantage as well. So I built this machine, and I was lucky enough it got some traction. I was on the BBC. I went to Moog Fest, and it's been a part of my practice ever since. Lots of artists and musicians have tried it out, including Sarah here, who's made some lovely pieces for it. 2, I think. So it's been an amazing project and a real privilege to have had that opportunity. So the next slide is for the nerds, if there's any nerds. So this is basically a little spreadsheet, a little rundown of what the different... so I would suggest, I'm not going to really go through it, but we can come back to anything on there. Feel free to take a picture on your phone or a screenshot if you're online. But it's basically telling you it's just a little summary of what the technologies employed were. And so this is, the next thing is a little video. So initially I had a bunch of musicians in the Goldsmiths Electronic Music Studios just show up and have a go on it. So this is like one of the very first phone videos. As I should say as well, I'm not the kind of musician who can really just, I don't think in score, and I'm not like a pianist. I don't know, I can just about tell a third from a fifth or something, but I'm not like someone who's that way inclined. So I was working with a variety of musicians and artists, but this little piece is James Bully, who is also one of the Oram archivists and a wonderful kind of sound designer and composer in his own right. This is him transcribing a bit of Messiaen's Horizon, which was originally for Ond Martineau and was derived from the quartet from the End of Time. But this is a nice little video. So this is literally when the machine is sort of 2 weeks old, or has been finished for 2 weeks. Quality footage, as you can see. I'm very fond of that video because it's almost like the first time it sounded like a musical instrument. Like my initial scribbles and stuff didn't really, and he just put something down that was just like, okay, this works. It sounds amazing. And so I'm just going to show you another little clip. Something I did a bit more recently. So one thing I also couldn't resist when I was designing the Mini Oramics was something that was different from Oram's approach, was to make it so that it was on the standard analog synth CV and gate, so volt per octave and stuff, so it can talk to other, just to have a bit more flexibility and integratability into other things. So I can use a different sequencer and play sound on here, or a keyboard or whatever, and I can also use this part to sequence other synthesizers, which is amazing. And another thing I couldn't resist building into it was just a very simple drum track, just 6 channels of triggers. And actually, I should go through what the different parameters are in a minute, but I'll just play. So this piece is Mini Oramics, but using the drum track to trigger another sequencer. So obviously it's a monophonic instrument, although you can have some intervals between the two oscillators. But so this one, I'm using it to make polyphonic music by sequencing another sequencer as well as playing the notes. So then, as I said, there's this second part of my PhD was this practice-based research, and these are my sort of conclusions. If Mini Oramics had been brought to market in the early 70s, and I think the timing here is really important because, you know, it kind of has to be pre-MIDI to have had really much of a chance, but yeah, she kind of left it too late. But if it had been brought to market in the early 70s, which was sort of how my research questions were framed around, it could have had a significant impact in electronic music studios around the world. It would have been cheaper than a computer at the time, but quite a lot more expensive than a VCS3, I think, like an early desktop synthesizer. Interface and sound unlike contemporaneous technologies, and I think that holds true today. I think the interface and sound are pretty unlike anything we have today, apart from it's analogous in a way to sort of a cue-based piano roll or something, but having the physical material really does make it differently. Like Sarah's always commented, there's no copy and paste, you know, every note and no erase. Well, there is erase. You get a bottle of alcohol and a cloth, and it's there is no copy and paste. Yeah. Oh, sorry, I meant to say at the beginning, if anyone has any questions in the meantime, feel free to interrupt me, but you can ask me questions at any point. And so the interface is more immediate and less painstaking than one might expect, you know, with the caveat that it's obviously not like a computer. There is no copy and paste. It is a perpetual prototype. It does need fiddling with. So it is a bit of a pain, but you can write, you know, nice lines of melody that are very expressive and, you know, musical, as I hope. You know, I think Oram would have liked it. I hope she would have. I think it fulfilled her brief. And in some ways, the original machine didn't, you know, it's arguable that her original machine didn't fulfill her brief in that the codified digital pitch and then the necessary lookup table is not, doesn't fulfill her brief. It's not an obvious, simple, analogous thing. It's codified. And on here, it is actually just like a piano roll. So maybe, I don't know, I don't know if you want to gather round and I'll show you, and maybe Matt can show the image of the top on the thing, and I'll take you through the parameters. Or can you put that on the screen? No. Yeah. Okay. Or we can put it on the screen actually, if you. Well, it's up to you. I don't mind. So anyway, great. So at the top, you just have one octave of 12 tones, basically one octave of a piano keyboard. It's the C, D, E, F, G. So you can just write the dots where you want them. And what happens is when the machine reads a dot, it will take that position, so it's G, and it will just stay there until it sees something that says change to something else. So you don't have to do like long lines or keep it there. It just stays where you put it. And then below that, I was optimistic in setting 8 octaves. It actually can only remain in tune for 6, based on the analog master oscillator. So I've locked out 2 of them. But so we've got 6 octaves where you can then basically place your G or your F sharp that you've specified in one of 6 octaves there. And then you've got 2 wave patterns that you draw on here. Can you, yeah. So those are your wave patterns that you draw in inverted commas. So these next 2 parameters on what you might call the programmer are the volume envelopes for those 2 patterns. The next one, similarly to her original machine, is how much reverb you add. And there's actually a spring reverb in here rather than an oil tank underground. And then the next thing is the analog vibrato / pitch bend. So again, that's a direct analog. If you draw a wiggly line, it will bend the pitch, and you can change how much it bends it with a depth control on there. And then the last part is the 6 drum tracks. So they're not complex. They just do a 5-volt pulse out, like a gate, a short little trigger pulse. There's no kind of dynamic control of anything like that. You would have to express those differently once you connect it. So I did have a Soviet drum machine I was fond of bringing to these talks, but one of the participants at the last talk made me an offer I couldn't refuse and bought it off me. So it's gone now. So that's So I'll play. I'll try and play this from the back. So this is a piece I wrote a few years ago, trying to sort of be a sort of homage to Hildegard von Bingen as part of a project that my now partner has been working on for years. Pause it there. And actually, what I might do is, if you can, on the back, you can see all of the sensors being triggered. If anyone wants to have a look, I'll play it backwards. So these boards, each board is a different parameter, essentially, that just sort of reads all of the pen marks and turns them into analog control voltages, essentially. So maybe we'll leave it there if there's any questions.
I have a question.
Yeah.
Has anyone ever like tried writing on it live?
Yeah, I've done it. Yeah. So you can. The reason I've designed the casing this way is like there's a gap under here, so you can run a loop. So I've done performances where I've sort of done a loop, put in some like very basic starting point, and then kind of built on it. But obviously it's quite painstaking to get stuff exactly where you want it. As I said, I'm not someone who can just be like, oh, the next note should be this and then that. Like conceptually, but it's not how. I'm much more of a kind of rhythm-focused musician, really, and whatever. But yeah, you certainly can do that. Recently, my partner Wando had a performance at the Barbican where she did that with more like on a reel-to-reel setting, but running it quite slowly and knowing where she wanted to sort of intervene, rehearsing it, and then rubbing out the bits before the next. You know, when she would rub out the bits she'd done and then start again. Yeah, so it has a lot of potential, and the only trouble with running a loop though is the bit of sellotape or the join sets off every sensor, so it's sort of like da 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 boink, and then you sort of so you can't really avoid this sort of like every 30 seconds boink, like yeah, but yeah, it's got a lot of potential, and as I say, yeah, it's fun trying to integrate it with other machines as well. Yeah, I should probably like demo the oscillators as well. If I come around here, just show you what the sort of timbre control is. Where is it here? So I've got the 3 volume controls for the different waveforms down the middle here. So if we're just listening to A here, we've got a filter so we can kind of take the edges off. We've got resonance, so we can make it gnarly as well. And then, but the main thing is obviously just changing the beat. So obviously, if it's flat, there's no variation. It's quiet, so we can make quite. You can kind of almost just like pull out the harmonics, and then you can also change the length, the number of samples. So this is 16, but I can change that. That's now 12, so it'll ignore these last 4, and it's a music. Some of the intervals are musical, and some are kind of random, arbitrary. So I don't know if like 16 against 15, is that a musical interval? I think Sarah did a spreadsheet once, which I've asked her for, and she has not given me. And obviously you can go really high. So then if I bring in B, oh, we have no B at the moment. Why do we have no B? Oh, we do. So we've got, so we can have it octaves apart, the 2 oscillators. Yeah, so that's your sort of basic timbre, and then obviously the reverb on there, and you can have reverb feed back until it feeds back if you want. Yeah, so that's yeah, it's actually a really fun synth to use with or without the programmer part. It's really fun with step sequences and other things as well. Any other questions? Yes?
This is fabulous. I'm really curious about, well, which bits are discrete and which bits are continuous, and I guess why, like, and how much of that is the same as the original Mini Oramics proposal?
So when you say discrete or continuous, how do you mean?
Well, like for example, with the
oh, you mean like
wave shapes,
stepped or
well,
I see what you mean.
For example,
Yeah.
like when we see the LEDs for the amplitude of the different
waveforms.
No, I guess those are discretized to some.
It's basically all of this is discretized. Yeah. So the number of lines here, you see the white lines essentially are all one digital sensor. So so there's 12 volume parameters, you know, so from loud to quiet. There's 12 obviously pitch parameters, 6 octaves. And yeah, so the 3 volume controls each have 12 discrete volumes, which doesn't seem like many, but there's also this series of slew limiters, which means it does slide between them.
Yeah, I see. Okay.
So, but the slew limiters are adjustable, so you can. So obviously with pitch and octave, it becomes a kind of glissando, but with the volumes, If you're doing a fast, busy piece, you set them quite low. And if you're doing a slow, long, drony piece, you set them a bit higher so that you get a more organic sounding. Yeah, so it's basically all digital at the front end, and then it's converted to analog control voltages.
Right, and then, but then I guess the timing in its own way must be continuous. Since I guess or is there any kind of notion of a time base in here? Is it just like the exact moment at which the comparator happens to trigger from the marker on the
So
slide?
the grid is only a guide. It's not related to the cellophane at all. It's just a guide so that you can say, oh, I'm going to set 8 of these to be a crotchet if you want, but it's completely fluid in the time section. Yes.
So therefore, you could like have one parameter slightly precede another, or the other way around, almost down to the kind of sub-millisecond level, if you were inclined.
If you're really accurate at drawing,
Yeah.
I mean, it's I remember James Bully saying, "Oh, the octave's not working. I can't get the pitch and the octave. If you want to change them both at the same time."
Yeah.
But it is literally just down to kind of getting your set square out and just making sure that they do trigger in a close enough together that you don't notice one changing before the other.
Right.
Yeah, it's kind of like that.
Yeah. Interesting.
Yeah.
Thanks, Tom. It's great to see the machine in the flesh after all these years.
Yeah.
I was really interested in what you quoted earlier on about her criticism of other electronic music devices at the time.
Yeah.
The question of timbre.
Yeah.
That in the end, the original Oramics machine is basically a very short sample, and actually it's quite a boring waveform.
Yeah,
And
you
so
can hear that in that radio sample.
All her,
Yeah.
all her hope for making, she has this fantastic musical imagination where she imagines something she can't achieve technically. And I sort of slightly, it seems to me that, do you think it would be interesting to try and, rather than the very clever device you've made, to try and do the opto thing? Would it be different?
It will definitely be different.
Yeah.
Like I say, they both have their advantages. But I think in a way, like, if we're talking like rich analog, what some people call fat analog kind of sound, then I think the CRT method is much more authentic. But like you say, it is a very short sample, and so is this. I think, I don't see that the sort of, if you've got 4 oscillators, I do think she designed out the boring. I'm not actually sure she got 4 oscillators all running at once. I'm not actually convinced of that at all, but she may have. I'm not sure. I don't think there's much recorded evidence that she really did, but I think she probably certainly got 2. And I think the fact that you've got 4, as you said, potentially quite boring waveforms, or they're boring in the form that they're static, but you can animate them by crossfading between them. You can set one kind of buzzy, harsh waveform and only use it for that initial attack, and then you can glide through another waveform that's slightly different, and then end off on a really rounded, smooth thing. You can fade, so I think she has designed out the boring in that sense, that you can morph between timbres in one note, and that every note is hand-drawn and has to be, by nature, dynamically different to the one preceding it. So, I think that's where I land on that. If it was just one oscillator, definitely, probably kind of boring. Yeah, unless you've got an animated filter or some other thing that's going to animate that sound. But I think the fact that you can, in theory, crossfade between 4 different.
Conceptually, she designed it out by meaning to have 4 oscillators.
Yeah, in that brief that I read out to you, she's sort of saying, it's not as simple as just attacked, and it's the timbre is morphing within the note, and that's what. So that's why I was sort of like, in her design for Mini Oramics, she actually had, instead of the ability to crossfade between timbres, she had a digital switching, which would, so basically in front of your oscilloscope, you'd have 3 or 4 waveforms, and they would be selected by having a DC offset to where the. So it's clever, but for me, it didn't fulfill that brief of this morphing of waves, because you could only switch. So I feel like this being able to crossfade between the two is more in keeping with her design brief. I feel like that decision of having this DC offset and switching is more of a compromise than what I've ended up with.
Yeah.
Yeah.
Very interesting. Thank you.
I think it's partly the fact that even if it was a simple waveform, the fact that it was drawn, you just by its very nature, like the difference between a mathematically perfect sawtooth and what she would draw as an impression of a sawtooth, you've immediately got richness there. And she spoke about sawtooths and square waves being about as inspiring as porridge because they were so perfect.
Yeah.
And it's also about bringing in imperfection of what the hand does, isn't it? It's a
she
massive
literally
part
says
of it.
I've got a freehand thing might give inherently more artistic results, doesn't she? And I think, I think that's true. But I think Tim's right that even a hand-drawn waveform, when static, is just going to be like, or whatever. It's not going to be exciting. It needs animating. But she designed in the animation, so, yeah.
Brittany.
Yeah, thanks for the presentation. So this is kind of alluding to the kind of like speculative nature of your research question. And so you kind of posited that if this were to go into production, you know, in the 70s?
Mid-70s, say, yeah.
That it would have changed, I suppose, kind of like, I don't know, popular thoughts on like musical creation, I suppose. So I'm wondering, like, if we fast forward now to the 21st century, like, what might music creation look like now if this were to come out in the 70s?
I mean, I kind of like to think, you know, obviously, if, say, this had come out in 75 and a few studios and a few musicians, you know, even if only 10 or 15 had kind of let it into their musical canon, you know, say a few composers, I like to think at the bare minimum, it would maybe be something akin to the Ons Martineau, where it was never a massive thing that was, but enough composers worked with it and wrote for it that it's still in the canon. You can still buy one. It's still a sound that's kind of unique. So I'd like to think it's at least that. And potentially it could have been, you know, those early music computing programs on your Atari ST or your Amiga or whatever thing were pretty blocky and straightforward. And people may have still said, well, this is the real deal. This is where I can get the organic, the natural thing. So it may have also influenced how software developers prioritized expression or feeling in what they were trying to do with their kind of crappy 8-bit sound chips or whatever. I don't know. I mean, I think it's difficult to speculate, really, but I sort of like to think at a bare minimum it would be something akin to an Ons Martineau, that there would be a small select few people who were, this was their instrument or this was part of their, you know, arsenal musically, and that, you know, some people would be still using it today. I would have hoped. Yeah.
I think the question of context is really interesting as well. I mean, you know, listening to, you know, some of the examples or hearing about somehow the original Oramics music was made. I mean, you can see that, I guess, her thinking was surely influenced by, you know, being part of a tape music studio. I mean, the idea that you would lay down a melody, you know, one line, then you'd go back and you'd do it again, and you know, put it onto tape. Of course, that's the kind of thinking that I guess you get into when you spend a lot of time making music and bits of tape, and you know, it comes through into the design of the machine itself. So, I guess my feeling is that you can't really understand the original Oramics machine without actually understanding the entire kind of studio context in which it would have been, well, either situated when it was built, or you know, the studio that she was working in before that. And I think what's interesting then about the mini Oramics that you've built is that I guess you're bringing in some of that context, but also some more contemporary context, especially the decision to have like 1 volt per octave, you know, CV outputs, for example. That situates it in a different kind of music studio, which is, you know, admittedly would have existed in the 70s, but is also something that's very contemporary to our time with the interest in modular and all of that. And I guess I wonder if you could say just a little bit about kind of what, you know, how you think of this as part of maybe a bigger musical ecosystem, you know, kind of outside of the sort of confines of the case and the controls on it.
Like, do you mean within like my personal practice?
Well, within your personal practice, or I mean, I guess because you're imagining also a kind of what would this have been? Is this the result of something that, you know, if it had been taken up by a commercial vendor in the 70s, I guess that was a sort of brief.
Yamaha or Korg or somebody had been like, we're going to make this.
Sure, yeah, exactly. But then there's probably also some bits of it that maybe are not responding only to the kind of 1970s, but also to the 2010s, even if the technology is one that would have existed 40 years ago. I mean, the idea that we kind of, you know, have sort of, that everything, you know, is modular and patchable or whatever, I mean, that's made a resurgence. It seems important that this happened in 2010. If you had somehow, you know, done this in 1990, it might have been a different set of ideas. So I guess I'm just trying to get at the sort of different overlapping chronologies that seem to come into the design of an object like this.
I think just going back a bit to Oram's, her mindset and her way of looking at what she was doing, I think she was a bit closed off. I think she had a kind of like, I'm doing this thing and everybody else is doing something else over there. And she designed both systems as entirely enclosed systems that wouldn't talk to anything else. And I think, you know, as you know, I've discussed at length with lots of people and in my thesis, she was pretty cagey about her intellectual property, or however you want to call it. And I think, you know, I just personally just think, well, it's more fun if you can plug it into loads of other stuff, right? Like, if I was clever, I would have given it a MIDI output, but I'm not very good at coding and microprocessors and stuff like that. But, you know, I was like, here's a simple way I can just make this more fun, more expandable in the future. And I don't think Oram came at it from that perspective in a way. It's hard to kind of get behind her thinking, but I'm not sure if that deals with, to some extent, your question. But the 2010s and modular, yes, that was the beginning of a resurgence of people liking hardware and patching and things like that, whereas before things have been much more laptopy and in the box, I guess. So yeah, it maybe has. I mean, I think my artistic practice and musical practice, kind of before that, has you know, a big influence on how I would approach something like this as well. Like, you know, before the resurgence in modular, I was making weird boxes that you could plug into each other that were kind of outside the modular ecology anyway. I don't know, and then they slowly integrated into it as it just became a really convenient format. But yeah, I'm not sure really where I'm going with that. But
yeah, no, it's really interesting. I think one of the things that makes this so interesting is a kind of, it's almost like a sort of practice-based conversation between Daphne Oram in the 70s and you now, in terms of saying, okay, I'm going to follow this up to a point, at which point I'm going to do this differently because this is what I want it to be for my music in this time. And I think there's a richness in that.
But I was certainly like, first and foremost, trying to make a machine that answered her brief, and then I can stick on some trigger tracks just for my own satisfaction as well, was kind of more, that was my little treat. But first and foremost, I was trying to answer her brief, for sure.
Thanks for the presentation. A few years ago, I used to be very into iPad music apps.
Yeah.
And I remember that there was one that was called Virtual ANS.
Okay, yeah.
And it was like an implementation of a hardware.
Merzin's ANS
exactly.
synthesizer,
So I remember that. I thought that when I knew about your machine at first, and the interface that the kind of like designing the sonogram and sonifying it was quite similar. And I always had this question in mind to ask you, which was, do you think that there was some sort of intermingling of ideas between Evgeny Muravin?
Merzin, I think.
Merzin?
Yeah. I have no idea if I'm pronouncing that correctly either. But
because there was such like quite an obvious convergence in terms of the interaction way of the interface of the optoelectronics and using that to sonifying. Do you think that there might be some sort of convergence between him and Oram?
I think I have found a document, and don't quote me on this, I think I found somewhere her writing a bit later, maybe in the 80s, that, you know, she was aware of the ANS.
Okay.
So, you know, she was really thorough in her research. She really was keeping a close eye on the competition at all times.
Okay.
She was reading all the magazines. She was going, you know, when she could, going to the conferences. She was exchanging these tapes and stuff. So obviously, behind the Iron Curtain makes it a bit more difficult. But she certainly was aware of it at some point. I don't know if she was aware of it. I haven't found anything where she's referring to it as she's developing. I can't even remember when the ANS was finished or whatever. Is it mid-60s?
I think it was similar around the same time. Because
I think she probably found out about it after she'd built Oramics.
Right.
But they're really different instruments. You know, obviously it's multi-timbral, polyphonic, whatever you call it. I mean, you can have 100 notes at once, right? It's a very different. This is much more cue-based piano roll, foundational philosophy of kind of a door kind of a thing, and that's you know, this very broad multi-timbral palette and a very So
I was just focusing on the interaction.
The drawing.
The drawing.
Yeah, the
drawing's
important.
sonogram.
Yeah, or the scratching away
Exactly.
with the ANS,
It's
isn't
like
it?
such an analog way of interacting with sound making.
Yeah.
I thought that maybe there was some sort of convergence.
Well, I think the what would you call it? The sort of impulse, the idea behind it of like, I think it's
very intuitive.
It's
right?
intuitive, and it's related to that spark of an idea of what I'd earlier on referred to as a universal instrument. You know, the composer, the score is the music, and it just, you know, I think the impulse is very similar, but definitely a very, very different beast. But the drawing though it's quite unique, I suppose, isn't it? Like like when I was doing the sort of case studies or the like getting people to evaluate it or give me feedback on what it's like to using, the drawing always came up first and foremost as like, wow, this is so different to use a pen than a keyboard or a computer or a mouse, or do you know what I mean? It's just so weird using a pen. It's like those sorts of things make such a difference to the UI, don't they? It's kind of exactly. All right. Shall we have a little break and then people can have a go on it?
Should we call it a day for? Bye. Thanks.